So let's start from example 60. Okay. Let's evaluate the integral that you see in the screen now. Double integral square root x squared plus y squared minus 1 dA, where D is the region bounded by in the first quadrant, bounded by x squared plus y squared equal to 1 and x squared plus y squared equal to 5. So when you read this question for the first time, you know immediately that you need to integrate this thing. So of course, I want you to think that you have 3 ways to do it. So the first way is you can use dx dy. The second way is dy dx. The third way you can use r dr d theta, which is a polar coordinate. So at this point, your knowledge, you can use these 3 methods already. So pick the one that you feel the most comfortable with. So the way that you're gonna pick, you need to draw a picture first. And as I suggest, if you feel like the equation is like a circle or something that is easy in polar coordinate, maybe it is suggest that you need to use polar coordinate. So first of all, I'm gonna draw the region D here, which it's gonna be this curve and this curve, which you can see immediately that they are circle. So you're gonna draw a circle, but to make the picture clean, we are looking at the first quadrant. So I'm gonna just do this and do this. And then I'm gonna draw a circle on the first quadrant. This is my Y, this is my x-axis. So I'm gonna say, oh, x squared plus y squared equal to 1. This is a circle, radius 1. Let's say it is this one. X squared plus y squared equal to 1. It is actually a circle, but I just draw it only the first quadrant. So you cannot see, in the second, third, and fourth quadrant. So another one is the red one. This is the circle again, but the radius is going to be not 5, okay? Radius is going to be square root 5. So actually it's going to be bigger. Okay, my scale is not good, but this is actually a circle, okay? But it looks like circle. But the radius now going to be square root 5, which before the radius is 1 for the green one. But for the red one, the radius is square root 5, which is this curve is x squared plus y squared equal to 5. Okay, so you need a region in the first quadrant bounded by these 2 curves, which is the one that I put the laser on. That one. So I'm gonna highlight it in green so you can see this part. Okay, this is what you want. And as we learned from last time and this week, we talk a lot about circles, and then we say that we're going to use polar coordinate when we face circle. And that should be your technique for this question. Because if you do vertical line, you need to split the region, and you're going to have to split the split the integral, and you have to do 2 terms. Gonna cost you more work, more minutes to do it. Or you do the horizontal line, gonna take you more time consuming, because you have to split it into 2 pieces, and then you split the integral, you integrate this thing 2 times. So the best way to do it is like, maybe we start from the pole. Let's think this one as a polar coordinate. You start from the pole here, trying to go this way. This way you don't have to split the region, because anytime you start from the pole, you go to the red curve here, draw the ray here, and then you can see every time they're gonna start from the the green one to the red one all the time, right? If you do that way, which is fine for polar coordinates. So we are going to use a polar coordinate, which means first of all, to use a polar coordinate, it is better that you switch all equations to polar coordinate first. X squared plus y squared equal to 1. This is equivalent to r squared equal to 1. right? Because you know that x squared plus y squared, that is r squared from last time, Pythagorean theorem, remember? And then here you have I equal to 1. Okay, fine, this is my equation. So this is I equal to 1. And then here, x squared plus y squared equal to 5. Is it similar to r squared equal to 5? Or r equal to square root 5? Which means this is the same equation with I equal to square root 5. So you know immediately that when you integrate, you're gonna start from this curve, which is I equal to 1. And then you're gonna finish at I equal to square root 5. Okay, set up the integral. So this is the question. I just copy the question first. Okay, this is your question. And then we're gonna say that, well, the order of integration that we're gonna use, we're gonna use r dr d theta. Okay, if you choose to do polar coordinates, dA here that I highlight in yellow, gonna switch to r dr d theta always. Again, remember one extra r. Do not forget to put one extra r here. Not just using r dr d theta, okay? Use r dr d theta because this is already, proved by mathematician that it's gonna work this way because you need to compensate something in order to switch the order of integration. And then inside here, this is a function that contains x and y. You don't want to see x and y. No more x and y because you want to use polar coordinate. So you need to switch this thing to polar coordinate as well. So what I'm gonna do, I'm gonna say square root x squared plus y squared. This is equal to r squared. So I'm gonna switch x squared plus y squared to r squared. The reason is because I don't want to see anything that depend on x and y in my goal here because you already switch it to r and theta. So everything that you're gonna see here must be in terms of r and theta. Okay. And then wow, now let's look at the hardest part. So the lower bound and upper bound here. So r is the inner integral. So clearly this question is not that hard because r gonna start from this to this always. So it's gonna be I equal to 1 to I equal to square root 5. That is 1. That is square root 5. And then what about theta? So theta is going to be what is the angle that you have to integrate with respect to, which is going to be 0 to pi over 2. How do I know? This is theta equal to 0. This is theta equal to pi over 2. So the angle of the ray that you have to draw gonna be 0 to pi over 2. If the arcs in first and second quadrant, so theta is gonna be 0 to pi. Does it make sense? So same concept with trigonometry that you learned before. Here gonna be 0 to pi over 2 because we only focus on the first quadrant. So once you have this thing, all your work for calculus 2 part done. So all you need now, integrate it. It's gonna be your Cal 1 technique. So how would you integrate this thing? Of course, use substitution, right? Because you have square root r squared minus 1 here, and you have r here, extra r here gonna help you because you have this, so you can use substitution. Okay, let's go slow way. Okay, let's go back to the original calculus 1 when you use substitution. So let u to be r squared minus 1. Then du by dr is equal to 2r, and then dr gonna be du over 2r. So I'm doing very slow here, which is going to be integrate 0 to pi over 2, integrate square root u, okay, that is u already, square root u, and then r. So dr gonna be du over 2r, and then d theta. This one, I equal to 1, I equal to square root 5. So I'm trying to go a little bit slow. So what I'm doing here is I'm just switching this thing to square root u because yeah, that's my u. And then r here, I'm gonna keep it because it's gonna cancel out with this thing eventually. And then dr, I'm gonna switch to du over to r by doing that. And then, well, as expected, this thing cancel. So you can pull out 1/2 now. Okay, that is 1/2. 1/2 that you pull out is from here. Pull out 1/2. And then now you're gonna have integrate 0 to pi over 2. Integrate. Well, this thing, you see what I did here? I'm trying to say I equal to 1 to I equal to square root 5. Well, because now you are integrate with respect to u. So I add my extra r equal to something here because I just want to keep myself on track that this is r, not u. So, and then, well, square root u is u to the 1/2, right? And then du, d theta. So, here, when I equal to 1, so you're going to have u equal to 1 square minus 1, which is 0. And when I equal to square root 5, you're going to have u equal to 5 minus 1, which is 4. So basically, this is 0 to 4. All right. And then you integrate it. So I'm going to do it a little bit faster. So 0 to pi over 2. And then that is going to be u to, well, u to the 1/2. So you get u to the 3 over 2 over 3 over 2 here. And then evaluate at u equal to 4, u equal to 0, and then d theta. Okay. And after you integrate this thing, so I'm lazy to do it. So I'm going to look at my answer. I already did it before. So the answer is 4 pi over 3. Okay. That's right. Yeah, the answer is 4 pi over 3. So basically, you can see that, well, this step you can fill in by yourself, but you know, this is calculate 1 technique. You plug in number 4, you plug in 0, and then compute the difference. And then you're going to have just the number here. So integrate theta from 0 to pi over 2, you're going to get pi over 2. And then you multiply 1/2 times pi over 2, and then times this term. So you're going to get 4 pi over 3. Easy. Right? Just the use substitution on calculus 1. But yeah, this is done for this question. So you can see that long question, but not much, you know, new concept. So you just need to draw a picture first, set up the integral, and then integrate it. Okay, that's all you need for this question. So any question on example 60, the first question for today? Any step you want me to clarify more? Anything else? Well, if you are good with this question, give me the sign, thumb up or anything. So I want to count how many people feel comfortable with this question. Good. Only 3. Okay, 7. Okay, better. All right, I hope you understand it because this is going to be one part of, you know, your skill that you need to have after you learn calculus 2. Okay, now I think I see question in the chat now. Okay, some of you have a hard time with your substitution here because you asked me why do I need to switch I equal to 1 to u equal to 0, because now my variable is switch from r to u because I do the u substitution. So the order, you know, the dummy variable here that I use now is this u. So this is why I have to change it to 0 to 4. Because if I use 1 to square root 5, it's going to be r. You can keep 1 as square root 5 if you want. If you want, you can keep 1 as square root 5. When you integrate it here, you can replace u back by r squared minus 1. And then you plug in I equal to square root 5 and 1 on this step. Okay. I would say that the black one that I wrote here, these, if you feel like this part, you feel like this part is your problem, maybe you need to go back and look at the substitution rule in calculus 1. This is the part that we learned in calculus 1, I think before midterm. Yeah, usually well, when we learn cal 1, we learn this thing before midterm. Well, it is possible that you forgot already, but you know, it's like the thing that we use it again and again. So make sure that you can do it. It's just, this is not like the harder technique. It's like just substitution, not by part, not trigonometric substitution. The way we do here, again, we do use substitution. Or if some students feel like this is way too slow, you want to do r dr squared minus 1 and then over to r here, I'm fine with that too. You can do that if you feel like this is quicker for you and then you understand that way, fine, because I can read it, I understand it as well. But if you feel like you want to go step by step, slow but sure, just do this one. So it's going to be a lot easier for you. And again, to answer your question, this number 0 and 4, it does come from here where I do substitution. So this u equal to this, if you don't know where did it come from, so it's come from here. So I equal to 1, so I plug in that, so I get u equal to 0. Okay. All right, so we're gonna move to example 61. So 61, let's evaluate the following integrals. So this one is harder than before because they give you the integral here. They want you to compute it. The problem is no picture and you know, no clue what you're gonna do. So if you try to integrate this thing without doing anything, let's try it first. So you're gonna integrate the x first, but you see that it's like, I don't want to integrate this thing because, well, integrate the x first. Okay, yeah, y gonna be constant. Yes, y gonna be constant. But how would you integrate x squared plus some constant to the 3/2? Looks impossible to me because, you know, how do you integrate, let's say, x squared plus 1 to the 3/2 dx here? Well, if or 4 here or 41 here, so any number, let's think from calculus 1, can you integrate x squared plus any constant 3/2 here dx integrate? Look like we have no way to integrate this thing. If you remember, like, we never learn any technique that we can integrate this thing. It's gonna be super hard. Even you try by part, trigonometric substitution gonna work for this one. If you do like x equal to tangent of theta, and then you do, you know, your nightmare from Cal 1, trigonometric substitution, then you do, it's gonna turn this thing to trigonometric integrals, and then you use trigonometric integral, evaluate it, and then change it back to x. It's gonna take you like 2 or 3 pages to do that. No, I don't want to do that. So the easy way to do this question is x squared plus y squared suggests that it's gonna be something related to a circle. Why don't we switch the order of integration to polar coordinates? Right, because dx equal to that and x equal to that would be a good sign that you need to do the polar coordinates. So let's start by looking at the domain first. The domain here is, well, follow me. X gonna be between that and that. So it means x is between this and this. And then y gonna be between -1 and 1. Right? This is just from the question, x from that to that and y from that to that. Let's look at the domain first. Hopefully it is a circle. If it is a circle, bam, we're gonna do polar coordinates. So is it a circle? So let's look at that one. So let's start from x equal to square root 1 minus y squared here. This is my scratch word. So I'm gonna square on both sides. So I get x squared and then 1 minus y squared, and then x squared plus y squared equal to 1. Wow, it is actually a circle with the center at 0, 0 as well. And this part as well, if you square it on both sides, negative side gonna be disappear, and then you're gonna get a circle as well. So basically, the picture that you have gonna be just a circle. Okay, we want to make sure that the region or the domain of the integration is the whole circle. So now I do expect that my region of integration, or the domain that we integrate with respect to, gonna be everything inside this circle with radius 1. Well, once you get the picture, make sure that you are correct with the picture first, because that is your first step. So let's try. If I have a circle here, if I want to do integrate dx first, well, dx first means you're gonna do the parallel line. Sorry, the line parallel to the x-axis, which means dx first, you're gonna draw a horizontal line, remember? So let's start by, if I do the horizontal line, what happened? It's gonna be that. It means every time you're gonna start from the left-hand side curve, at the end, you're gonna get the right-hand side curve. The left-hand side curve here, it is actually the circle x squared plus y squared equal to 1, but it is on the left. So if I simplify it, so it should get x equal to x squared equal to 1 minus y squared, and that is x equal to square root 1 minus y squared. I use negative sign here because x is on the left-hand side. And then on the right-hand side, it's going to be another curve, which is the same equation, but it's going to be x equal to plus square root 1 minus y squared, which means if I draw a horizontal line, so it's going to start from x equal to negative 1 square root 1 minus y squared to x equal to square root 1 minus y squared. Perfect. And then y gonna be from negative 1 to 1. Perfect. Because this is negative 1, this is 1, and the range that you draw vertical, a horizontal line gonna be from negative 1 to 1, which means we are on the right track. So this is going to be your picture. The entire circle with radius 1, center at the origin 0, 0. This step is the hardest step for this question. Every time when you see the question of integration for double integral, the hardest part is when you decide what to do first, like dx dy, dy dx, or r dr data, and get the picture. The rest of the work, it's going to be the routine work from calculus 1, or the part that you set up the integral. Not that hard. The hardest part is going to be you need to get a picture first. That one is the hardest one. And this question, the picture just, the picture is already hidden in the integral. So you need to get the picture first. From my experience, I found that students had a hard time the most on this step, because it's gonna take you a while to get the picture from this. If you don't, be smart with your equation here, because some of you are gonna say that you start from this thing and then you stuck because you cannot get this picture. Trying to get the picture first, push everything you can about this equation, trying to draw the equation, and then, at the first shot, you probably get different regions. You can double check with yourself on the time if you are correct by, double check with the question again that this is the region that you are looking for now. Okay. All right, so I'm gonna keep going on this one. So once I get the circle here, easy for me. So I'm gonna say in double integral. So I'm gonna switch now to r d theta. And then once you change to r d theta, what is going to be the inside? What is it going to be the term inside here? So x squared plus y squared is r squared by Pythagorean theorem. Sounds good. And then 3/2, keep it there. And then now I'm looking for lower bound and upper bound of my integrals. So r gonna start from where to where? So let's look at that. Well, we start from the pole, which is 0. And every time 0 go to that, go to that, go to that, go to that. Well, circle is just easy way to do polar coordinates. So r x squared plus y squared equal to 1. This is the same thing with r squared equal to 1. This is the same thing with r equal to 1. And then, you know, so every time you start from 0, which is the pole, to 1, which is circle. So pole to circle, pole to circle, pole to circle, pole to circle. Keep doing it until you get the entire circle, which is theta from 0 to 2 pi. Simple. And then now you integrate it. So 0 to 2 pi, 0 to 1. This is, okay, be careful with this thing. R square, and then you raise everything to the 3/2. So 2 gonna cancel out. So you get r cubed, and then you have one more r here. So this is actually r to the 4th power. Make sense? Be slow on that algebra because you can get mistake easily. And then you get 0 to 2 pi. This is r to the 5th power over 5. And then from 0 to 1. This is going to be indicate 0 to 2 pi 1/5 minus 0 d theta, and then that is actually 1/5 indicate 0 to 2 pi d theta, and that is 2 pi over 5. You can see that once you switch to polar coordinate, it takes you very fast to integrate this thing, because this integrand, you have no problem with x squared plus y squared, right? Because you switch it to r squared and you can simplify it easily, and then woo, everything just turns to r to the 4th power, and it's gonna be super easy to integrate. Okay, sounds good. Then you can see that this type of question, again, the hardest step is when you're trying to understand this term and get the picture. It's gonna be like this every question for polar coordinates. You can see that this question is still not that hard for the picture because pretty clear on the description, so you can draw a picture easily. But
John, your power is wrong. It's not 3 to the power of 4, it's 3 to the power of 3. R to the power of 3.
This question?
Yeah. Where you R to the power of 4, it's R to the power of 3.
This one? You mean this one?
Yeah.
Well, I'm going to go slower than this. So let's look at that one together. This is r squared to the 3/2. So this is just r cubed. I agree with you. But this is one more r. So
sorry, I didn't see it. Yeah, I didn't see it.
Yeah. So, well, I did it too fast, sorry. So I grouped this thing and at one step. So it's r to the 4th power. But yeah, it's actually better for you to do it in 2 steps. Yeah, but well, my head just went too fast. Sorry. So it's r to the 4th power. All right. I hope you can follow this one. Okay. Gonna be this type of question for sure on like question 8 or 9 on the final exam. So it's gonna be something like that you need to practice so you can do this one. So we have 2 more, okay? 62 and 63, and gonna be the end of the class. You can see 62 and 63. So when I give you an integral here, double integral, so I give you that one, no picture. So you need to translate this equation to the picture first. And I feel like that one is hard. And then after that, you set up the integral, and then integrate. This question is give you easier tasks because you don't have to integrate anything, because they just want you to switch the order of integration from dy dx to polar coordinates. Once you set up this thing, you are done. They just want you to set up, convert to polar coordinate. they say that, oh, you can skip the integration part because we are not going to give you the function, so you can integrate. So once you set up, you switch the order of integration, you are done. Well, I love this question more because you don't have to integrate, you know, because as you see, the integration part here is, this is just calculus 1. Okay, so example 62. Well, we're gonna get the picture from this thing first. So everyone, if you remember the technique that we learned from the first week after Songkran, I told you that better to write out the domain first. It's gonna be y from 0 to square root y minus x squared, and then x from 3/2 to 3. All right, this is the hardest part now. So how do I get the picture from this thing? How do I get the picture from this thing? So first on, well, trying to draw everything as many as you can. So everything that you can think of, draw it. So the first one is, well, I see this equation looks the most complicated now. So I'm gonna simplify this thing and trying to get this picture. So I'm gonna say y equal to square root 9 minus x squared, which means if I square it, so it's gonna be y squared equal to 9 minus x squared. Okay, and that is gonna be x squared plus y squared equal to 9. Okay, my picture gonna contain circles somewhere. Okay, y and x. Well, I'm going to draw a circle with radius 3. Whoa, sorry about my scale because I use pen. I didn't use a ruler. So this is 3, negative 3, negative 3. Okay. Okay. I know there's gonna be some picture like that too. The first one. So the second one is, okay, I need to draw y equal to 0. Okay, y equal to 0 is like this axis. Okay. So to make sure that, okay, I'm gonna do the thick blue line here. This is y equal to 0. And then we're gonna do the thick key line here. So let's look at x equal to 3/2. So 3/2 is going to be 1.5, something cut half between 0 and 3. So it's gonna be that. So x equal to 3/2. And then x equal to 3 is that one. X equal to 3 is this line, x equal to 3. So now we are looking for, well, you have to think which one that you are going to integrate with respect to. So my guess is that y start from 0, and then, well, it's mean like every time you do dy first, it means you draw a vertical line. Every time you're gonna start from y equal to 0, and then you're gonna hit the circle at some point. So my guess should be that one, or this one. Right? Because every time when you do y from 0 to square root 9 plus or minus x squared, well, you need to start from 0 for sure. You're gonna hit circle on the top. So it's gonna be this part or this part. Which one? A or B? So let's look at x. Well, but x needs to be between 3/2 and 3. Yeah, so for those of you who already got it, so you're gonna see that the best part should be this one, should be this piece. Yeah, it's gonna be the one that you are looking for here. Good. Well, this is not an easy step, you know. When you listen to me, well, you follow me, so you feel, oh, it's easy, Ajahn. But when you do it by yourself, it's gonna be a little bit tough for you to get the picture, because you need to be clear on the picture that you have. You know, once you get it, I would recommend you to double check again that, oh, if I do dy dx, I do that. So it's, yes, right. So it's gonna start from 0, and then you hit the circle. Yeah, it's gonna be like that. And then x gonna be 3/2 to 3. So yeah, the range will be that one. So now we're gonna switch to polar coordinates. Okay, let's do that. All right, so I'm gonna change x to r cosine theta, right? Y to r sine theta, and dy dx gonna be r dr d theta. So what I did here, dy dx gonna be r dr d theta, automatically by the theorem. And then fxy, I just plug in x to be r cosine theta, plug in y to be r sine theta. But you know, you cannot simplify any further. This is just already done for this part. All you need to put lower and upper bound, and that will be full credit for this question. So you need this. So what is your upper bound and lower bound here? Well, this is not easy question. As you can see that when you start from the pole here, and then you go using the polar coordinates. So every time, yes, you're gonna start from the green line and then you hit circle, right? But at one point you stop. You can see that one. I'm gonna use the back dash line here to be your stop here. So every time you do that, yeah, look like you're good. You're good to go because you're gonna start from the green one to the circle all the time. And but your theta gonna start from theta equal to 0 to this theta, which you don't know what theta is. You need to find it. And then, well, let's start from the R first. So how do I work with the R? So I know that I'm gonna, every time in the dollar array here, you're gonna start from, well, to get this region, you're gonna start from the green line and then you hit the circle, right? So this term on the lower bound of R here must be the green line. And on the top here must be the circle one. Okay, so but the circle now is, well, the circle is x squared plus y squared equal to 9, which is similar to r squared equal to 9, which is similar to r equal to 3. So the top one here is number 3, because you're gonna hit circle all the time. How about x equal to 3 over 2? How would you switch it to polar coordinates? So we learned last time that x gonna be r cosine theta. So it means r cosine theta equal to 3 over 2. If you cannot remember, go back to the last lecture. Well, x equal to r cosine theta. Okay, and then now r gonna be 3 over 2 cosine theta. Right, because you divided by cosine theta on both sides. Or if you want to simplify, it's going to be 3 over 2 times sec theta. If you feel like you want to simplify cosine to secant, you can. Well, it doesn't matter. You're going to get full credit anyway if you leave it as a cosine. So 3 over 2 secant theta. So this is the upper bound and lower bound for R. Good. Well, any question with dr here before we move to d theta? So anyone have question with dr? So any step that is not clear for you? All good? All right, so now let's move to more complicated part. So what is going to be your angle, right? Because now the part that you feel like you want more angle, you want to find theta here. So let's see how you're gonna do it. First of all, so one thing that you can do is you do 0 on the bottom for sure, because you're gonna start from here, theta equal to 0, right? But you need this line, what is going to be theta equal to something. In order to get this line, don't you see that you have the right triangle here? Yeah, I saw in the chat that use tan theta equal to y over x. Yes, that's what I want to say. So thank you, Akari, right? Your name. So that you mentioned that thing, because you see the right triangle here. And we learned in class that, well, you can find this theta by, if you use the opposite over adjacent. So tan theta is going to be y over x. So basically you have tan theta equal to y over x. From here, you hope that you're going to get theta from there. So you hope that from here, you're going to get this angle theta from there. which means you need to find this point. Because if you find this point, you're gonna get the value of y and x, right? Because if you get this point, this is going to be your y, and this is going to be your x. Okay, so let's find this point. So this point, the intersection that I put the laser on now, so it is on the line x equal to 3/2. So which means this point, the x coordinate going to be 3/2 for sure. And if you plug in 3/2 into the equation of the circle, you're going to get y. Okay, so I'm going to plug in, well, take times. So plug x in, you get 3/2 square, and then plus y square equal to 9. And then that is 9/4 plus y square equal to 9. Y square going to be 9 minus 9/4. 36/4, which is 9, minus 9/4. So this is 27/4. And that means, well, I'm sorry that I did calculate this thing too fast, but you know, just to save time. So y here going to be 3 square root 3/2. So let's suppose that you hit everything in a calculator, and then you already get that y is 3 square root 3/2. It's gonna take time for you to get y. If you can go slow, fine. But what I did here, I plug in x square plus y square equal to 9. So I solve for y, so I get the coordinate here, x and y. So this is my x, this is my y, and then I'm gonna just plug in here, so I get tan theta. Okay, tan theta equal to y, 3 square root 3/2, and x, which is 3/2. That means tan theta equal to square root 3. That means theta equal to pi/3. Okay, so the answer gonna be just pi/3 here, because we actually get the coordinate here already, which is this point, and then you hit the equation tan theta equal to y over x, so you solve for theta. Any question? Am I going too fast, too hard? Okay, so this is x and y, and then you just get well, now you have this tan y here and this tan x here, which is this x, this is y, so that is tan, and then well, so I put in here tan theta equal to pi/3, so I know it's gonna be pi/3, because tan 60 degree or tan pi/3, that is square root 3. Right, 60 degree, right? Am I right? Not 30 degree, because the tan 30 degree is going to be 1 over square root 3. So tan square root 3, I'm sorry, tan pi/6 is 1 over square root 3. Tan pi/3 is square root 3. Yeah. I'm not good at trigonometry too. Sorry, sometimes I get confused in myself, but yeah. All right, so long way to go, but eventually we get the answer here. Yay! So questions? All right, so let's see the thumbs up for this question. Let's see how many people still survive for this question. So show me the reaction. How many people? Okay, only few people this time. Good. All right. Okay, so we're gonna move to the last question. Okay, for this class, this is going to be the more complicated one, 63. So any question on example 62? Well, if this type of question show up on the final exam, it's gonna be the question that they're gonna cut you for A. It's like 62 and 63. This is going to be the question that I feel like if you can do it, you should get a good grade, because this is a complicated concept. All right, so example 63. Let's look at this one, the last one for this class, and then we're gonna wrap up the class. Okay, look, I'm gonna tell you a little bit more about the final, the format of the final, and then yeah, we can take a break after. All right, so example 63. So I want you to convert the order of integration from the x dy to polar coordinates. Again, this question do not need us to require, this question we do not need to integrate this thing, sorry. Well, let's do that. So now the x dy to polar coordinates. Okay, again, x from y squared to 1. Let's do that. X from y squared to 1. And I have y from 0 to 1. All right. Sounds good. Next, well, I'm going to get the picture. All right. So first of all, I have y squared equal to x. Well, this must be parabola, but you know, in different axes. So this should be, how do I get parabola? Well, the regular parabola is going to be that one. That is y equal to x squared. But if you have x equal to y squared, it's going to be this way. Okay. So that way, let's make it more fat here. X equal to y squared. All right. And then now I have x equal to 1. X equal to 1. Let's say it's this one. X equal to 1. Okay. How do I know? This is x equal to y squared. This is x equal to 1. And then now I have y from 0 to 1. So y equal to 0 is that. Y equal to 1 should be this one, right? Because, you know, you can find the intersection here easily because when you have x equal to 1, it's going to cut at x equal to 1, y equal to 1. And x equal to 1, y equal to negative 1. Because you can plug in x equal to 1 here. So in this equation, so you get y to be plus or minus 1. And this intersection, you can obtain it easily by looking at the picture. You can eyeball and see that the intersection is 1, 1 and 1, negative 1. Now, what is going to be your region of integration? So my guess, because we're going to cut y from 0 to, it's going to be this one, right? Because, you know, let's guess that the region that we're going to integrate with respect to is the green one here. All right, so make sure that everything is all right before we continue next step. So we're going to say, okay, let's start from, if I do the x dy, so I'm going to do the horizontal line, which means that. So every time on the left curve, going to be parabola. Perfect. The right curve going to be the line here, x equal to 1. Perfect. So, and then y going to be from 0 to 1. So yes, so we get the picture. We get the picture already. Okay. Now, hard part. Let's look at how I'm going to zoom in because the picture is going to need to be more clear in the picture. So I'm going to start from the pole here. You know, always start from the pole for polar coordinates. You do that. 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 It's going to be, well, the picture is going to be super small. But you can see that the pattern looks a little bit odd because you're going to have one line here. Well, I'm going to put the orange line here. The dashed one. You're going to have one line here that you split the region of integration into 2 pieces. It's going to be from the pole to the purple line on the first piece. On the second piece, after the dashed line here, going to be from the pole to the parabola. You know, this piece is very small, but it's going to be from the pole. Well, in order to get the region on this piece, it's going to be from the pole hit the parabola. Does it make sense to you? This means you're going to have the pieces number 1 here and number 2 here. The number 2 is going to be that small pieces after the dashed line here, which means the order of integration here for our polar coordinate, you need to split the region. Okay. So we're going to do double integral f r cosine theta, r sine theta, and then r dr d theta. So this is going to be your first one. And then plus double integral f r cosine theta, r sine theta, r dr d theta. This is going to be the second one. Okay. This is because the picture, well, as I told you, parabola is not easy. Well, if you want to do polar coordinates, it's going to work with circle. But for parabola, it is not easy. So you have to split the region. Well, okay. Yeah, parabola is it's one thing that is not compatible with polar coordinates. It's a little bit hard to work with parabola in polar coordinates. So let's start from number one here. So number one here, every time you start from the pole, you see, and then you're gonna draw the lay here. It's gonna hit the purple line up to this point and then just stop. So this to purple. So the pole gonna be, yeah, pole gonna be I equal to 0, no radius, yeah. But this line is x equal to 1. So let's switch that thing. So x equal to 1 is x equal to r cosine theta equal to 1. I equal to 1 over cosine theta. So actually this is I equal to secant theta. Well, basically, it's gonna be 0 to secant theta on the first piece. Sounds good. And then what is going to be the theta where you on the first integral? So it's gonna be something that you start from 0 here, theta equal to 0, up to this part, theta equal to 1. Yeah, the dash line here. So anyone know what is the dash line? Tell me in the chat. Anyone know that one? What is going to be the angle that you do the dash line here? Remember, it's past 1, 1. So it's symmetric. It's part 1, 1. So which means this is 1. This is 1. Tan theta is 1. So what is the theta that you give tan theta equal to 1? Yeah, I saw a lot of students say pi over 4. Thank you. So good. That is pi over 4. Make sense? This is theta equal to pi over 4. How do I know? For those of you who cannot follow, say it again. So this is negative. This is, look at the picture. So it's past 1, 1, right? So 1, 1 here. The pole is 0, 0 here. So you are trying to get the equation of the angle here, because you know that this is going to be your y, which is 1. This is going to be your x, which is 1. So you're going to get the equation tan theta equal to y over x, which is 1 over 1, which is actually 1. So what angle that you're going to get tan theta equal to 1? So that angle is pi over 4, or 45 degrees. Yes. So which give you this from 0 to pi over 4. Okay. And then, well, the first piece is clear. So the second one, so here, you're going to keep doing it. It's going to be pi over 4 to pi over 2. Pi over 2. Make sense? Pi over 4 start here. You keep doing it until, yeah, it's going to be very small, but you're going to keep doing it. One, it's just get to pi over 2, you stop. You agree with me? Like pi over 4, and then go, and well, at the end, when it hits pi over 2, it's gonna be like no length at all, and then yeah, you're gonna stop at pi over 2. So which means actually, well, for theta on the second piece, it's gonna be pi over 4 to pi over 2. You know immediately from the picture, it's gonna be like that. And then r, what is your r here? So it's gonna be from the pole again, but now this time you hit parabola. So it's gonna be the pole, which is pole is I equal to 0. So let's switch parabola. So this is the line. So let's start thinking about parabola. So it's y equal to x squared. What is the equation here? Sorry, x equal to y squared. X equal to y squared. So which means x equal to r cosine theta, y equal to r sine theta, and then you square. And then we'll go slow. So it's going to be r cosine theta, and then this is going to be r squared sine square. Okay. Well, luckily r cancel out. So cosine theta equal to r sine square theta. So here this is because I cancel r on both sides. So r disappear on both sides, and then well, I have 1 r left on the right hand side here because I cancel 1 r. And then I have r equal to sine square over cosine. I can keep it here, and then just answer this going to be sine square over cosine square. That's enough already. But for those of you who want to show your trigonometric skill, this is the same thing with secant times tangent. Well, same thing. Well, if anyone want to use secant times tangent, fine. But if you want to stop at sine square over cosine, fine as well. And this is how we complete this question. So any question should be A level for this question. Like the person who want to get A should be able to do this one. Isn't it cosine theta over sine square? Oh yeah. Thank you. Well, sorry. Thank you for yeah, that notice. Well, embarrassing teacher. Okay. Yeah. Cosine over sine square. Yeah, you're right. Thank you for those of you who correct me. Yeah. It's like, yeah. Because I did it too fast. Yeah. Oh, yeah, this is 1 over secant and tangent if you want to simplify. Yeah. Ugly. I don't like trigonometry. It's so ugly. Is that right? Yeah. Yeah. Okay. All right. So questions. Okay. So I think a lot of you, I saw at least 3 students now direct message to me how to get pi over 2, because this is the part that is the hardest one. Okay, so let's talk about this thing again. So can I draw another picture here? So I'm gonna just zoom that one. So it's look like well, I'm gonna just make it more factor so you can see it. It seemed like that what you did before, or what we did before, is we're gonna start from theta equal to pi. Well, let me put the scale on. This is that. This is pi over 4, we already compute. And this is actually going to be pi over 2, right? Because the orange one, that is going to be the scale from trigonometry. You all know that. When you draw this thing, it's gonna be theta equal to pi over 0, theta equal to 0, right? And then you keep doing it, it's gonna just keep coming. Well, the first piece is easy because it's gonna be theta to pi over 4, clear to you. But for the second piece, a bit tricky because you start from pi over 4. If you keep doing it, it's gonna be like that. So you can see that the ray gonna get the length of the ray that you draw gonna be shorter each time. Like, because every time when you keep hitting your theta, just keep getting close to pi over 2, the ray gonna be very small, very small, very small. And at the end, when pi over 2, it's just going to stop. Right? When it just get close to pi over 2, they still have a length here. Because you need to eat it all. You need to eat all the area of the region D here. So if you stop at this point, it's gonna be just only this piece. So you still need more and more. At the end, it's gonna just stop at pi over 2. You cannot go further than pi over 2, because if you go over further pi over 2, it's gonna be this way. It's gonna be like different piece of the region that we are integrate with respect to. Does it make sense? A bit tricky here that you need to understand picture very well to see that this is pi over 4 to pi over 2. Make sense? All right, so this is pi over 2. Well, technically this is the hardest part for this question, because yeah, I mean, this piece is going to be the one that will. Thank you for those of you who have a question on that thing, because yeah, can you explain how you get the outer bound for the area piece 2? Yeah, that's the one that I already answered. Okay. All right, so I think I answered all questions in the direct message. All right, good. So any question